All right, before I get started, I just wanted to say that this is a very special an event apart for me because a lot of times people ask me, like, are you self-taught? And I think what they mean by that is, do you have a degree? And I don't have a degree, but I was taught on the job by some really amazing people, and one of them is here today. And I think that those teachers and mentors that teach us things like, I mean, she taught me CSS and like way back in the day, really bring forward the best of our capabilities. So I want to give a big round of applause for all teachers and mentors, but most Misono Allen in particular. All right, cool. Animation on the bleeding edge. So usually I get up here and do something like this. I teach how to make performant animations in the browser and the basics, but you know, it's gotten a little boring.
Hey.
Sorry. Anyway, today I want to take us a step further. Today we're going to push the boundaries of what's possible on the web and what can exist on the web. So before we talk about the future of animation, let's first talk about the goal of the web. The web is first and foremost about communicating. And we can communicate happiness, and we can share memes with each other. We can communicate our fears and talk about politics. We can educate. Ultimately, when you break everything down, what we as humans are trying to do on the web is communication. So what does this have to do with animation? Why would we need to care about animation in order to communicate? Well, let's think back to your earliest sensory memories. I want you to think back to the first time media, not something in your life, but media made you feel any one of these things. Could it have been these? Maybe it was Spirited Away, maybe it was Up, maybe it was Toy Story, perhaps it was WALL-E. How about something that made you feel all of them? We have happiness.
Boo. Boo. Oh, look at that. Yeah, you know. Oh, that's cute. Yeah. Boo. Well, that's very nice. Come here, you. Oh, he's a happy bird.
Yeah, there's this.
We have fear.
Nothing's coming out of your closet to scare you anymore, right? Yeah. Goodbye, Boo.
Kitty.
Kitty has to go.
We have sadness. We have curiosity.
Boo.
You see, emotions attach to the limbic system, making things easier to recall. If I asked you what happened randomly on some day when you were 5 years old, you might not remember, but you probably remember all the words to Hakuna Matata or Under the Sea. These cartoons may have seemed like basic line drawings and entertainment, but they gave color and shape to our imaginations. They brought life to our internal worlds. Part of the reason it could do this, what was then exciting and is still so exciting to me today, is that anything can happen. And that's why when we talk about the future of the web and the future of what's possible on the web, we talk about animation. My name is Sarah Drasner. I'm Sarah Edo on Twitter. As mentioned, I'm on the Vue core team. I'm a staff writer for CSS Tricks, and I'm also head of developer experience at Netlify, which is neither Netflix or Shopify, as much as my parents are confused about that. It's actually a really easy way to deploy your sites. You can either drag and drop a folder and deploy it straight away, or you can connect it to GitHub, and every time you push to master, it easily deploys. But here today, I'm here to talk about the web's bright future. We're going to start with some things that you can do on applications that you can work on today, so things you can implement right now, and then we're going to push beyond that into the future, and some things that might be possible but aren't available yet. Okay, so first let's talk about making your site a little bit more intuitive by using page transitions. And we're going to build off this first example for a while during the talk, so we're going to start with something a little bit more simple and keeping on building off of that to show some other richer experience. So to create beautiful page experience, we're going to use a tool called Nuxt. Nuxt is Vue's version of Next.js if you work in React. It's very similar. It has server-side rendering, code splitting, page transitions right out of the box. And you can use all of those without ever stepping outside a Vue file. So if you there's a pages directory. If you put a Vue file or a component inside that directory, it becomes a page. It already routes everything for you, which is it's pretty cool. So if you're familiar with Vue, and even if you're not, that's a really, really nice way of creating routing through a whole application. So if you're not familiar with single file components, this is what they look like. In that template is where you have all of your HTML. In the script is where you have all of the corresponding scripts that you'll need for that component. And in that style area is where you have all your styles. So they're all kind of in that one file. You can use the scope tag and make all the styles scope to that one component, but it's optional. You don't have to use it if you don't want to. Typically what we do is have one or a few global style sheets, and then very, very specific things live inside of those components. So that's what those look like. So you'll be given an index page in the pages directory, and if you create a simple Vue file with a Nuxt link and create a duplicate and make them point back and forth, you get a fully routed single-page application with server-side rendering without ever stepping outside of one of those components. So I live-coded a Vue app, a Nuxt app from scratch. If you're interested in more about that, you can check out that link there. Otherwise, we'll keep going. Okay, so there's something more. In Vue, we have a thing called a transition component, and it's a way for us to coordinate entrances and exits with animation. It applies hooks for which we can create these animation effects. And what's really nice about Nuxt is it offers us that hook right out of the box. You don't have to wrap anything into a component. You don't have any overhead. Just by adding these classes to your application, you can apply animation logic in there, and then all of a sudden you have entrances and exits for every single page. Now, this isn't such a big deal for page entrances, right? Like as soon as something enters a page, you can apply animation. But it's a little bit tougher to apply something on exit. As soon as you click a link within your application, it wants to go there right away, right? So this will actually pause for the length of the animation without it writing any weird callbacks or any kind of thing. So you just put those animation classes in. So pretty cool, huh? So you can do things like this. Never do things like this. I'm just messing around. Don't do this to your users. But there's all sorts of opportunities for entrances and exits. But of course, my favorite thing are JavaScript hooks, because we have a thing called transition modes, which are what help us coordinate when we want those entrances and exits to occur just with one line of code. So it's a way of declaratively stating, hey, wait for this one part to fire before firing something else. So you don't have to write a lot of that animation logic. And a lot of people might say, like, well, why do you like JavaScript for animation? It's not that I don't like CSS for animation, but there are some things that are really great for CSS and some things that are really great for JavaScript. For instance, if we look at cubic Beziers in CSS, you can see that they have two control handles, right? So that's great. We can adjust them. We can make all sorts of different eases, but we are limited to two Bezier handles. Whereas with JavaScript, we're not limited to two Bezier handles. It's infinite how many Bezier handles we can have. So with one thing, and we can also have custom animations too. So if you wanted to make a bounce effect, right? In CSS, you go up and down and up and down and up and down and up and down and up and down. Where with JavaScript, you might be able to just say from here to here, and the ease is a bounce, and it takes care of all of that for you. So if you want those kind of dramatic eases, sometimes JavaScript can offer some really great things, and GreenSock as a tool is really good for that. Cool. So we can create these really stylish transitions per page. You can see all of the mountains and letters will switch up per page, and it's different every time too. So we can have different page transitions per page just by adding it to each component. So you can see that each one changes, and it's all done with SVG. Sarah Sweden is going to talk about SVG a little bit later on, but you can see how that makes it very responsive. I didn't have to do a lot of work to create this really responsive and cohesive experience on mobile. So okay, here's a repo where you can check out that code, but this is just the first step. So now let's take it further. The web has come under critique in recent years for appearing a little outdated compared to iOS and Android experiences for animation. We are allowed to, on those iOS and Android experiences, have these nice transitions that are seamless when we're using those apps. But a lot of times when we're working on the web, those kind of things can be a little bit harder. And so one of the big things here is that when you're scanning a page, you have to redo all of that logic every time. So I'm going to show you some ways that you don't have to do that, and we can retain those cognitive experiences for our users. So when we move from page to page, here's a heat map of your eye. Every single time you see different information, your eye has to rescan all of that material, so it can introduce cognitive leaks. Even if that element is just placed a little bit to the side, you have to remap that space. That's what your eye is using an event called saccade to kind of try to understand evolutionarily what is going on in the field of view in front of you. So how can we reduce this cognitive load we incur on our users and maintain state? I love this example by Kathy Sierra from Badass Making Users Awesome. She uses this example of the stove, which I think is just so great. Every time I go to the stove, I go, wait, which one goes this way? You know, it's just like this mental activity that you have to do. And by just rearranging things slightly, we remove all cognitive leaks. I all of a sudden know exactly what knob is associated with what burner. And that didn't cost us anything, right? That didn't cost us a lot of things in order to retain state for the user, make it a lot more easy to use, make the UX a little bit more efficient. So recently, Jira made an update to their UI where they grouped all of the similar information in similar categories. So this is what it used to look like, and this is what it looks like now. But I think what was really cool about this was how they showed this update. So when they showed the update, they showed how they found the similar information and then how they grouped it, which helps me understand what decisions were made here. It helps me as a user go, I see, these are similar pieces of information, and they're all getting grouped together, and that's why it feels more cohesive. So what we're communicating here is a way that humans can understand those connections and links a little bit better. Motion can help with that because it's time-based. So we can do this in that Nux tool I just showed you. So if we wanted to make something like this, which is an application on the web that just has these different pages that we're going to where we're having slightly different things per user, per page, we're switching the users out, but it is the same kind of way of working, right? We're not remapping that entire space every time, even though there's new content. So how do we get working with an experience like this? So first, we're going to set up a Vuex store. A Vuex store is like, if you use React, it's like Redux. If you don't use either, you can think of it a little bit like the application brain. It's the thing that holds all the state for the application. So let's say you're signing into an application and you're a particular user. That brain would hold what user that is and dole it out to every component. So in that Vuex store, what we're going to do is we're going to store what page we're on, and we're also going to be able to, that mutation allows us to update what page we're on. So that's really what we're doing, is being allowed to tell all the components what page we're on. And in order to do that, we go into middleware and we say, okay, when the root context changes, when the page changes, let me know what page changed, and I'll commit that to that store so the brain has that information. And then we're going to register the middleware in Nux so the application knows, okay, that's there, we're using that, that's available. And then in layouts default.view, so I mentioned that we have everything inside of a page. There's this basic layout that we use for all Nuxt applications. And that's really great because every page is routed through that Nuxt element right there. It means that if we want something to stay on every page, like we don't have to add it to that navigation or the footer to every single page. We just add it here, and then it's on every page. And by that, I don't mean that it's added to every page. Every time you link it, it's coming back on the page. It's literally persisting on every page. The nav and the footer can persist on every page. So if we wanted to move things around but retain state and just change out the content, that's one way of doing that. So in our app nav transition component, we're going to detect the page and create some conditionals on that page stored in state. So to see how the animations themselves are implemented, because there's a lot going on in the application demo, I made a reduced test case so that you can play with, so you can see a kind of smaller view. It's a little bit more clear what's going on. So what we do is wrap that main navigation that persists in a transition group component. The transition group component is interesting because it applies flip under the hood. How many people here knows what flip means? Like a few, yeah, usually not a lot of people. So flip is a technique to create really performant animations in the browser. It stands for first, last, invert, play. And what we do here is we take all the coordinates from the first element, all the coordinates from the second element, and find the spaces in between them and calculate that and use transforms. But that sounds complicated, right? That sounds like a lot of work to do for every single element, especially if you have a lot of elements, but that's when the performance really pays off. So what the transition group does in Vue is it applies it all for you, just automatically. So you wrap it in this transition group component, you apply a CSS class, and then it does all of the calculations, which is really nice. That means you don't have to do all of those calculations. So especially for something where we have a lot of those pieces moving, this is really nice. So we wrap everything in this transition group. So it basically looks like an HTML element that we're wrapping, and all the elements contained in it are going to be able to have this flip technique applied. So then we add some styles. We're basically going to say, this goes over here, and this goes over here, and anytime it moves around, we're going to apply this transition. So we can have these beautiful per-page animations that make use of this technique. Transitions are really great because we can say, start here, wherever it's going to and coming from, apply the animation in the middle. So now you can see how you would make all of these beautiful page transitions per page using Nuxt and page transitions. You now know how to do all of that. And if you're not using Vue, that's okay. I have a demo using Vue and Nuxt on pagetransitions.com and that GitHub repo. Simona Koten did a fork to Angular and TypeScript. Sean Wang Swix did a fork over to React and Next. And if you're not using a framework, you can use this tool called Animate CSS Grid, which also allows you to make all of these kind of layout transitions happen without a framework. So for those who are interested in vanilla JavaScript or CSS, this is another option for you. Okay, so we looked at some great ways to create seamless page transitions, and as you saw, those were also responsive. So at this point, we're all pretty familiar with responsive design, right? It's been around for a while. We accomplish a lot of things using media queries and grid and Flexbox. So what if our websites weren't just responsive in 2D, but in 3D as well? What if the browser offered us some basic specs to hook into to create these kind of experiences with ease, just like Flexbox and media queries? So let's say you're browsing on a phone and you want to see more of a piece of information, so you can pop it into even just like a kind of cheap VR headset. And then at first it's kind of similar to that desktop or the mobile experience. But over time, you can start to make these experiences that actually really adjust to this experience. And think pieces fade out, you can start to look around, and you can see if you're trying to figure out where you're going hiking or some travel experience, this is a really good use case for this. You can actually get a sense of what that place really looks like. So I made this demo using that same page transition technique using Nuxt page transitions, as well as Three.js as a basic proposal of what this could look like. So we're looking around, let's say we want to go to Amsterdam, we want to find out if this is the place we want to head to, and you can see we can pan around this area. So on the page itself, we capture the coordinates of the mouse or the head as it moves, and we'll update some transforms as well as perspective origin on some of these DOM elements. We'll also create sphere buffer geometry. So in Three.js, I'm making a circle, and then I'm going to put the camera inside of that circle. I'm going to make a circle, I'm going to apply that scene inside of that circle, and then we move the camera inside and move it around with Three.js so we're placed in the middle of it. But what's important here isn't how it was made today. What's important here is how it could be made in the future. So if we have a div and we want to make it round, we can add a border radius, right? And then it becomes a circle. But what if we had something like a media query for VR, and we could do something just with CSS that said, hey, how about a material of grass? What if the spec allowed for this? So what if, some of you might be familiar with CSS filters. What if we had CSS filters for all of a sudden three-dimensional experiences, and we could apply some material like env-map and reflectivity without learning all of Three.js in order to apply it? So this is a leaked screenshot of the Chrome DevTools, so what might be on the horizon for what's coming out with 3D in the future. And if you don't know Josh Carpenter, you should definitely go follow him on Twitter. He posts really amazing stuff. He works on these Chrome DevTools, and he works on this spec moving forward for some of these VR experiences that might happen on the horizon. So here's a detailed view of a chair and what that might look like. What if the DevTools allowed us to place elements as primitives and just move them around with some CSS features? Cool, huh? So in fact, the team in charge of making these primitives was led by the same people who created A-Frame. And here's a demo showing those small primitives, and they make up these complex scenes, but you can also see this visual inspector where you can move things around and move them up and down, and you can update the placement of all of them on the fly. So here's a tiny demo I made in React, and it's just to show how A-Frame works when I combine the two. I have just a bunch of squares moving around and blocks, and I can kind of pan around that scene. And if you haven't seen A-Frame before, this is what it looks like. You have these HTML elements that make up the camera, the cursor, some light entities, but I'm not writing all of this in JavaScript, right? I'm writing it all in HTML. And this is an older demo, so it's still using animation classes, but here, using React, I'm adding an array that I update each one of the boxes using some primitives, but also some variables to change things up per box. And I also created this little hotel chooser on Glitch, and it's actually a fork of one of A-Frame's own demos, so it's very similar to that, but I feel like this is an actual use case that we could use. If I'm visiting a hotel, I might want to see what that experience is like before visiting that. You can see if you're looking around that hotel in order to decide where you're staying, that could be really helpful, right? Instead of seeing a few static images. So here's how we created this. I'm going to show you all the code for this whole demo, not even just like a piece of it. This is the sky. Here are those thumbnail links and a plane that was behind it so you could see them more clearly. And here we have some click timing and stuff. This is all written in HTML again, and you're just loading a different image for the background every time you click on something. That's the whole demo. That's all of the code that it takes to run this demo. So actually, the authors of A-Frame are even creating their own browser. So this is like progressive enhancement gone wild, right? Because it does work like a regular browser, but if you're VR enabled, it does so much more. And they're also reducing the barrier to entry for this kind of creation and design as well. So instead of needing all of this kind of 3JS experience and experience with all of these models, you can actually create these experiences inside the browser too. So it doesn't end there. What if we had the building blocks for this to explore augmented reality as well? What if the browser let us extend what the user was seeing and some information contained within it using native specs? Right now we can do something like this using ARKit, but what if these experiences were available to us using JavaScript, APIs, and CSS? So think about how it could advance teaching, our tools for teaching. If you have to learn chemistry from a book and the periodic table of elements, are you more likely to remember all of those static diagrams? Or what about if you could see how things combined? So which are you more likely to remember? This reduces the cognitive load to nothing. You see things and you see literally how they're connected, and they stand on their own very directly. And you could apply this to learning other tactile things like piano. If you think about it, you're really associating notes with the fingers and the notes on the keyboard. But what if you used something that actually allowed you to make that connection a little bit more directly? You're seeing how the notes are played on the piano. You're seeing how long you'd have to hold and press each one. So then you can actually make that connection, and it reduces cognitive leaks. So what I'm going to show here is Smithsonian worked on this Autodesk view to scan the vehicle for the first lunar landing. It used to be that you could only see inside the first lunar landing vehicle through this tiny little window, and now they have this scan so you can see the human elements of the entire ship.
Lunar landing in a concrete form and sort of index it. It's a table of contents, a way to provide a more meaningful access for the young person who just would be thrilled to know what it was like inside of a spacecraft that went to the moon and back.
I'm really inspired and excited about how maybe this 3D scan could inspire future generations to do great things.
So this is an ability to see inside and have a more human experience with this instead of just seeing a capsule and peering inside. So that's really nice. And then this AR expedition is also really great because spatial awareness is really
important.
important.
Who wants to see a volcano? 3, 2, 1. Wow! Look at that lava, look at that smoke coming out of that.
Pretend you're an airplane and fly over the tornado.
That's the top of it. What do you see?
It's either asteroid, meteorite.
We're learning about DNA and genes, things that we can't see. And so the most exciting thing for me with the AR technology was that I could see kids get an aha moment that I couldn't get by just telling them about it.
The minute I saw it pop up on the screen, it made me want to get up and walk to it.
We actually get to turn around and look at things from all angles, so it gave us a nice perspective.
See if you can figure out what that might be based on what you know about the respiratory system.
I got to see where the alveoli branched off, and I could look inside them and see how everything worked, which I never saw before, and it was really, really cool.
Because spatial awareness is important, how big things are relative to us, how we look around it, how we explore it. We live in a world that's in 3D. We live in a world that's in motion. People often think of these experiences as additive, but static 2D is an abstraction. Without motion, without seeing things in 3D, we are actually creating some cognitive leaks. We're actually creating a bit of friction to understand how it complements our reality. So some of these experiences can actually help people learn. Because education isn't the only place that 3D can be useful. Seeing things as they are and how they take up space, we can understand products a little bit better. We have a better sense of how those things might fit into our hands, how they might fit on us, how we would use them. You can see in this product demo, all of these different pieces give us a better sense of that equipment. We're not seeing 5 different images and putting them all together as a composite in our mind. So you can get a sense of how they would feel like to hold them. It might seem arbitrary, but it can be really beneficial. In Aditi's post, How Virtual Reality Benefits Seniors, she talks about some of the research she's done at Microsoft with VR and people who are elderly. One of the participants was overcome with emotion as she told us she had macular degeneration. The VR experience was the clearest she had seen in over a year. And there are even games like Sea Hero Quest, where seniors can play, and based on the way that they orient themselves, we can check for early signs of dementia. When you start to get early onset dementia, one of the first things to go is the ability to navigate yourself. And previously, we would have these control studies where we'd invite people and pay them to come into an office. We'd have some control subjects, and we'd have the senior citizens play. But with a game that we can deploy to so many people, all of a sudden, you're not limited to a small data set. You can deploy it to many, many, many people all at once. The data becomes much more accurate. And then this has already benefited many seniors and helped them get treated early, which can actually reduce the way that this dementia treats, or the way that this dementia comes about in people. So I'm really excited to see how these things are used in applications in the future for some of these medical benefits. And beyond that, what would happen if some of our books and experiences could also be a little bit more interactive, a little bit more playful, and we could become part of each scene? Or what if it wasn't limited to interaction, but progressive enhancement in book form?
That get added.
A couple days ago.
Pretty cool. This goes up and down.
So this book is a book no matter what, right? And it's a beautiful book. It works either way. Even if you don't have an AR experience, even if you don't have an iPad, you can still enjoy this book. But if you do have an iPad, you can see these kind of additive AR experiences where things are animating around.
Yeah, it's just like all kind of flying over your book.
And it's also quite fun. What if learning was so engaging that you never wanted it to end? This is actually one of the engineers that worked on the Smithsonian, that space pod that we saw earlier, the Smithsonian Autodesk project. I mean to show this to you because it's really engrossing, but I just think that she's really cute also. You should definitely follow her on Twitter. She's a genius. She makes all sorts of really cool stuff. So remember this from before. This isn't just a metaphor for how we perceive animations and drawings, it's also how we create them. In old cell animation, we broke these pieces down into smaller bits, and then we allowed them to become reusable to convey things like depth. So we'll talk a little bit from the design side now. So when we have these experiences, we can have many different layers that are applied on top of each other. The movies of the past used these before. They used techniques just like the ones we just covered.
The problem was how to take a painting and make it behave like a real piece of scenery under the camera. The trouble was we were photographing a flat two-dimensional background. So we set about making plans and blueprints for a new cartoon camera that would overcome this. The different elements in the scene were separated according to their varying distances from the viewer. This put the moon on a plane farthest away from the camera. With our original picture broken down in this manner, it is possible to control the relative speed with which each individual part of it moves to or away from the camera. But the moon remains absolutely still, and so it will always remain the same, neither growing nor shrinking in size. Of course, our cartoon camera does not shoot sideways, but is placed above and shoots downward toward the drawing. Since this new camera used many planes, we called it the multiplane camera. Here now is our same moonlight scene the way the multiplane camera sees it. As you can see, we finally got the moon to keep its proper distance.
Isn't that amazing? That's 1957. We still don't quite get that on the web. And I also love the drama of it. It's like the camera, boom, boom, boom. Should get up here and do like buffer arrays in 3JS, dun, dun. Anyway, I think that that's really amazing. So if we wanted to, just like in that video, explore how we would design for experiences in these three-dimensional spaces, it might seem kind of crazy or hard to do. But what we figured out is there's some basic rules for all of these different planes and fields of view. One of them is that you need to have a horizon, or you can make people sick, so you should definitely have a horizon. Another is that you can have these front, back, and sides, and it's kind of an infinite canvas all around us. So if we place something, a widget or something that we're working with directly into this space, well, it doesn't quite work, because what happens is once we look inside in that VR view, it starts to look a little bit warped. It starts to bend in this kind of strange way. So if we follow the lines, you can see that they actually, when they look curved inside of that flat view, they actually look quite straight here when we're looking in the VR view. So instead, we have to think of that field of view and accommodate for that warping. So if we change our, the dimensions and, change the way that those widgets work by folding it along those fields of view, you can see how we can place all of these things here. And then when we look around, we can look around to the front, left, and side, and then all of a sudden it doesn't seem so complicated to make an experience like that when you start to follow along those grids. And you can start to see how you might make an experience that is all around you or designed for it. So we can do something like this. And this, it just uses the same premise, right? So we're taking that grid and we're warping those objects along that and plotting them based on that field of view. And if I showed this to you earlier and said, make this happen, you might say, I don't know. I mean, I would have said, I don't know. But knowing that there's some, grids and, barriers that we can work within, some constraints we can work within really help. So we've forged into the world of 3D, right? But what if we take this one step further? What if we break free of even the input methods of the past? What if we're not in a realm where we're even taking in things like mouse clicks and using keyboards in order to work with things online? What if we're making things happen in a hands-free experience? We talked a little bit about healing and accessibility earlier, and Val did a great job explaining a lot of accessibility and motion pieces, but let's take it one step further. Okay, so I'm going to start with a personal story. Many years ago, I worked at the Field Museum of Natural History as a scientific illustrator and a web developer. And at that time, I was a consultant. I didn't work there, full-time. I came into work every day and was paid consultant salary. One day, I was getting on a bus to go to work, and the driver didn't see me, and he closed the door on my hand. And he started to go. And he didn't stop the bus until everyone on the bus was yelling, and I was yelling and stuff, and I heard a pop in my wrist. That popping sound was the sound of tendons in my wrist ripping. And because I was a consultant, I couldn't take time off of work. You know how medical insurance works here, right? So I had to keep working through the pain. So I can show you what happened through applications that I made, but it's a little bit less clear. So I'm going to show you through some drawings I made at the time. I worked through the pain, and I started by, this is the kind of art I was making at the time where I would do, this is a ballpoint pen, and I'm just building up these strokes with tiny little lines over and over and over again until it gets this kind of thinned out view, so it's like cross-hatching gone wild, sort of. And at first, I couldn't do these kind of ballpoint pen drawings. I couldn't build up that tight shading or gradient. It was too repetitive for a ripped tendon. Then I started doing these etchings because they're actually just a little bit looser than what I was doing before, so I started working with these etchings. But even that started to become painful. So then I started doing these kind of more loose portraiture, and you can kind of see how the brushstrokes start to fall apart a little bit more, which was not kind of my style before this, right? So I'm, using these kind of thicker brush strokes that could fall away. And then eventually I couldn't use my right hand at all. I started using my left hand to paint things, and you can see that this is definitely a lot different from where we started from, right? But eventually I started to fatigue my left hand as well because I was leaning on it so heavily, and I started to have a difficulty doing everyday tasks like brushing my teeth. So I had to do something that was really difficult. I had to slow down. And you see, rest seems simple, but painful, imposed rest for months at a time is actually incredibly difficult to do. And doctors know this. So they invented this system to teach people what they're doing to their body when they're re-injuring themselves. Tendons and some injuries like that, you can't just put in a cast and say, be done with it, because you do need to actually still have some movement or it can heal improperly. So you have to be very careful in the way that you heal. So this process that I'm referring to is called biofeedback. This is a really interesting process. They hook you up to sensors, right, all up and down your arms and into your brain, right? And you're sitting in a chair, and what they're trying to do is when you get stressed out, you get this flight or fight thing, right? You've probably heard about this. And what happens in flight or fight is that all of the blood drains out of your hands and goes to your head to think and your feet to run away. But if you have an arm injury, that means no blood is circulating through your arms, which means blood carries oxygen. That's how we heal, right? So that's not very good. So they hook me up to all these sensors, and I'm sitting in this chair, and they tell me to think happy thoughts, and they put on some classical music, and I get very relaxed, and so I'm thinking of all these happy thoughts, and in 2 minutes, I raise the temperature in my hands by 10 degrees. Right? That's really cool. So they're showing me how the stress and what motions I was doing actually affected me. But then I'm, a naturally curious person, so I was like, okay, well, I'm going to test the machines. I'm going to just see what happens if I think something stressful. So I think about something stressful, and the machine crashes, and the beeping, and she's like, what are you thinking about? Stop it. So, after that point, that was when I was sold. I was like, all right, this is a real thing. This is something that I'm actually doing to myself to make myself better or worse. So I thought, okay, what if we did something like this on the web? What if we had a hands-free experience where we could give people some feedback based on what they were saying, what they were thinking, and we could see adjustments based on what they're thinking. So my coworker, Brian Holt, and I, when I used to work at Microsoft, worked on a project that used natural language understanding, or LUIS, that connects to a view application so people can see a visualization based on what they're thinking.
Excited. More. 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 Nervous. Tipsy. Less. Less. Less.
Okay, so to see how this is made, I'm giving you like a bird's eye view of this application. Basically, that Vuex store, the brain, sits there. It holds all the state for the application. We have some components, some dependencies, and we're calling out to LUIS. Okay, so that's basically what that application looks like. So in the Vuex store, we're going to use a counter to adjust the visualization. We'll have placeholders for the intent and the intensity, the intent being the emotion that I was saying, and the intensity being more or less, so up or down. Initially, we're gonna hold a UI state so that I can see if we're idle, if we're listening to somebody, if we're fetching something, and so I can track what's going on in the application and make sure that the application reflects those changes. Just a quick note on that, I always store that as a string, not a Boolean, because application state very rarely is just Boolean based. Eventually, you're gonna have to refactor that to be a string probably, so it's good to kind of start off with a string. So we have this idle, awaiting user input, listening to user input, fetching user data from the API. So you might have noticed that at first we activated the UI by pushing a button. We don't really have to do that. It can listen continuously if we want. But since this is a web application that I'm showing people, I do want to make sure it's okay with them first, that I'm recording their voice. I don't want to do that initially, unless you have their permission right off the bat. So here we activate that UI by hitting a button. Then that will set the UI state to listening. And we'll also record what the user is saying to be used in get understanding, this get understanding thing that we're going to use in a second. In get understanding, here we're going to use Axios to post to Lewis, and we're going to send our subscription key as well as the utterance here. So I'm going to send that thing that we listened over to that natural language understanding. So we set the UI state to idle and commit a mutation that will change the state of our intent. Now, if we log into the dashboard, this is how we train that model. We go in, and I can say app.com, app.excited. I could have added anything, and I could have also not done app. But I wanted to make sure that it was kind of namespaced here. So I added a bunch of different intents, calm, excited, frustrated, happy, and then we also have the intensities, which are more and less. And if we go into one of those intents, so if we go into calm, I'm basically training it with words that are similar to it. It's a little like feeding it thesaurus things. So as soon as I train it with data, I'm just giving it words that are associated with that and the more words I give it, the better it gets at understanding it. And then I hit a blue train button at the top, and it trains that. So that's actually not too complicated to train one of those models, right? We're just adding it into this dashboard and training it, and then it goes, okay, I get it. Anytime somebody says something like, I'm fine, I don't know why I put placid in there, that's a weird word. I'm untroubled, things like that, it goes, okay, we're vaguely talking about this calm idea. So here, once we've created the relationship between the store and the intent, which is the emotion, we're going to adjust the intensity, of course, too. So we're going to use a counter that goes up and down in order to change that intensity. So what we're going to do in the visualization itself, the visualization is a torus knot. It's just a shape that's moving around in three-dimensional space, and I used a kaleidoscope effect to reflect it up and down. So it's just reflecting. We're seeing a little window into that torus knot shape moving around. Anytime I change the more or less, the camera goes backwards and forwards. That's why you see a slightly different view of it. It gets bigger or smaller because that camera is going back and forth. And then for the emotion, I'm changing the way that it looks. For Tipsy, we had crazy colors, right? We just covered it in crazy colors. For Frustrated, I changed it to a wireframe. So you're just seeing the wireframe of that space, and then it looks a little bit more tingly or something like that. But you can make it do anything that you want. So here in the components itself, we're creating that visualization, and we're going to update it based on the intent that we saw. And here we're going to use buffer arrays in order to update. They help tear down and reinstantiate a lot of objects if you ever use 3JS. That's important information. If you don't worry about it. So here, we're also going to animate this. We have several methods that we're using, but one I wanted to call attention to is this. We're using request animation frame, so we increase the rotation, and then we're also rendering the scene. So every time this request animation frame happens, we change that rotation a little bit more. But we also use a watcher to plug into Vue's reactivity system. So what watchers do is say, like, okay, anytime something changes, we're going to react to the change. So what we're reacting to is if someone said more or less, we're going to do something. When someone says more or less, we're going to tear down the shapes, and we're going to reinstantiate them with the new shapes. So we're going to cancel the animation and then restart it. And what you saw there is just the first step. So the next thing I'm going to do is hook it up to a headset. There's a few different headsets out there. This one's called Muse. There's another one called Emotive. And it senses your brain waves, so the visualization can be instantiated this way, and then you can control it with your voice, and you can have a completely hands-free experience. And I'm not the first one to do this either. Charlie Gerard has been working on this same concept with an Emotive headset. So this is an example of her pushing a 3D cube by thinking about it. And now, in terms of accessibility, even people who are not able to use their hands on the internet can create these great experiences on the web and do so through their voice or their thoughts. So we've already accomplished so much, and there's so much out there for us to use and explore. So why do I feel like, as Jen Simmons puts it, that we're in a rut shaped like this? Why are we still making sites like we have static table-based layouts when we have all of these opportunities to make things on the web? Jen's not the only one who noticed this. This tweet resonated with a lot of people. We make the same sites again and again, and none of them are very memorable. Remember how emotions attach to the limbic system? How are people going to remember your experience on the web when they feel nothing when they visit it? It's time for us to take up some space. Hopefully some of the things that I showed you today become beautiful primitives in the web of tomorrow, but I also built them with existing technologies today. It's time to expand our minds beyond the rectangles of the past. As we noted before, anything is possible. So my question is, what are you going to build? How can you, in your everyday development life, push the boundaries of what's possible? How can you create something that doesn't currently exist? How can you create your dreams out of code and share them on the web? Because after all, that's the purpose of the web, to build, to share, and to communicate. Thank you.